him. Okay, thank you, Vittorio. Thank you, students. Have a nice lecture.
Thank you, Franca. Bye. Bye. Okay, so I've started the recording, so we can start with the actual lecture. So last time we have seen some examples on how to access REST API, and let me just switch slides. Okay. And we've seen some example of accessing the REST API through, some command line queries that we did by following the REST API specification of a very simple, API which was serving jobs description, and we saw that how resources in this API were accessible, and what does it mean to access a resource or a sub-resource which is addressed by an identification number, and we saw some example of specific queries to that API through, for example, limiting the amount of results that we wanted, and so on. And just to finish up with the presentation on how access the REST API, I would like to show how it is possible to access a REST API by using the browser, by using the JavaScript environment that is available in the browser. And so how to access an API, the same API, the job API that we've seen last time from the browser. So to do that, I would like to open the developer tool window of the Chrome browser, and just 1 second. So let me share the developer tool window. Okay, as you see, this is the developer tool window of the Chrome browser. It is a window that is it is an environment that actually helps you test JavaScript code that is then inserted into a web page. I guess that you're probably now very comfortable with the JavaScript development and browser environment in the browser. So to access within the browser the web API, you typically want to use the fetch function, which is available. It's available in the most modern browsers. It's a standard function to produce requests towards endpoints to actually get data from them. And several days ago, you would have used Ajax or any other similar mechanism. Today, there is a standard function which is called fetch. And with the fetch, you specify, hopefully it's the let me just enlarge so that you can see. With the fetch, you just specify the address of the endpoint of the resource that you want to access, and you specify also that you want to, this is a way of taking the results of the fetch function that does the request and then gets the JSON data and prints it on the console. So if you go into the documentation of the fetch function, you will see why it is necessary to use the .then notation, which is a way of concatenating asynchronous calls to. In fact, in JavaScript, everything it's asynchronous, so you must have a way of concatenating functions which are asynchronous. And in the end, the second, the last thing that we do is printing the results of this fetch request. And of course, in your code, you might probably want to do something else with the data, but in our case, we are just printing it on the console. And so, if we press, we see that we get the same data printed on the console of the browser, the same data that we got while playing in the command line with the same API. So that's pretty much it for what concerns getting data from a REST API from within the browser. You must really use a single function call and specify the resource and the optional query directly from within the fetch argument. So having said that, let me just open the chat to see whether there are any questions about this. Otherwise, we can go on with our exposition. So we've seen how to play with an existing API, and now I want to show you what does it mean to write a specification for an API. Let me just switch back the slides. Okay. So what does it mean to specify an API? So a specification, it's just a document which somehow defines and describes the conventions that are used for expressing the resource names and the overall number of allowed operation, always in terms of get, post, put, and so on. And in general, in this part of in this course, we are going to use the OpenAPI standard for producing specification. Keep in mind that this is just a description that we're going to, a formal description, if you want, that we are going to use to somehow fix in the stone, as I could say, the capabilities of our API. And we're going to see that having such a formal description of our API will allow us to generate some starting code for developing the server. So we are not going, by writing this specification, we are going to be able to get a skeleton version of our code of the server, and also some documentation from it. So it's going to be an effort that you do at the beginning, and but it will be very worth the time to do that, because we're going to get a lot from it. Otherwise, of course, you could start from scratch, defining with pen and paper the API. But in our case, it's we're going to really exploit the OpenAPI for doing that. And API specification can be written in YAML or JSON. And to see how this is done, I would like to take back the original API with which we had played so far, and show you what is the actual specification of that API. So you can see in the slides the link, which is the link to the skills API, and you can see this is a JSON description of the overall API. And there are a bunch of metadata that are associated with the API. There is a description, contacts, and so on. Swagger, the original, the field that you see up inside here, it's Swagger. It's the version of the OpenAPI standard, which once was called Swagger, and now it's called OpenAPI. We're going to use this as a synonym for that. And there are a few other metadata that are pretty much more or less self-describing, but the thing that interests us, it's the part that starts from the paths field. So much like function calls in programming languages, all the operational resources return a representation of those resources with a sort of type. And the example that you see here, for example, it's a specification of a get operation done towards the jobs resource path. And as you can see, it stipulates that the returned information must adhere to the following to a type definition of the object that is going to be returned. So let's delve in right into it and describe field by field what we're doing. So here we're describing a get to the overall jobs resource collection, and there is a summary and description which are self-describing, and then we have the parameters. The parameters section specify in this case the optional query that can be provided when you access the jobs API just after the question mark. If you remember, the query part of the URI fragment can be used to specify some options, and here we specify what this option can be for a query to the jobs API to be valid. And in this case, the first example, the first parameter is offset. We have used it last time to play with the API, and this offset must specified in the query path associated with the URI, and it has a description, of course, and it has also a type. So you might specify also that, for example, the type of the value associated with the offset must be an integer or text or so on. There is all the available types are available on the OpenAPI specification. So I'm not going to delve into all the possible ways to specify the type. And and the response field describes what can be the actual the structure. What is the structure of the object that is returned by the call to this API endpoint. And by the way, when I talk about endpoint, I talk about the URI of a resource. So it's going to be a synonym that I'm going to use for that particular description. So in this case, the responses are described in terms of what can be the actual. So as you might know, HTTP as a way of communicating back to the original requester whether there has been an error or the request was successful. And here you can describe what can be the actual status codes that must be returned by the server to the client, and what structure is associated, what object is associated with that particular response. And for example, for the 200 status code, which means a success in the HTTP protocol, we say that the returned object, so the description of the resource that we're going to return, must have the following schema, which is a way of describing the structure of the object. And as you can see here, the schema is described with a $ref and hash definitions jobs. This is a section of the same file that we're seeing, which describes how the jobs object is built. And typically this section is defined in the same file, and we are going to at the end probably there are a lot of, okay, let's go down. Okay, here we go. So in the definition field, we find all the schema definitions associated with the jobs actually. So the jobs object, it's an array here. The type is an array of items. Whose structure is described in the job field or subfield of the definition, which is just down here. Okay, here jobs, and as you can see here, the job is described as a structured object with a set of properties. Each one is a type, and you can have also properties that are again structured objects and so on. So it's a kind of hierarchical structure so there is a kind of a hierarchical structure associated with the object type, and it's more or less I think self-descriptive in the sense that whenever you the API encodes the fact that whenever you return an object and whenever you respond to a request for a jobs object, you must return an array of objects. We're talking about Json object also, of course, and those jobs, those objects must adhere to the definition in terms of field and values associated with the job object. So this is a way of more or less describing types in a statically typed programming language. Okay, so it's a way of encoding and setting installed the actual types and calls to the endpoint in order to really having them as a contract, if you want, between the client and the server. So having the OpenAPI, having an OpenAPI specification of our of the resources that we want our server to be exposing to the clients, to the browsers. As I said before, it's very useful because we can take this. I'm going to copy this this whole file and go to an online editor, which is called the Swagger editor, which is an editor of OpenAPI specification. That means that let me go directly to the site so that I can show you what does it mean to. Let me, as you can see, there is an editor window on the left, and there is a section of this on the right. There is a white window where we're going to really see the documentation that is automatically generated from the API that we described. And I'm going to paste the description of the skills API that we've seen before. I just want to convert from JSON to YAML. Okay, let's go. And as you can see, directly from this specification, the documentation is generated. And okay, nice documentation. What is important is that, for example, if you remember, we described the way in which the call to the jobs resources must be composed. Okay, and the fact that we have described it in so much detail and somewhat formal definition in terms of types that must be used and what we expect, etc., allows us also to have automatically generated documentation that is also executable. That is, we can, for example, if we link it correctly, the host, the server that is serving our API in our description, then we can also execute example calls where we can provide parameters as we specified in the API and check for responses. So this is going to be a way of really helpful way to test your API once it has been specified, so that you can really verify that it does what it is meant to do. Okay, so this is one thing that is very important. And the other thing that I would like to that is very important also for us, it's it's here. It's the on the generate server menu item. Here you can, from the specification that you wrote here in the editor, you can generate code, skeleton code for several programming languages, and we are going to generate example code for the Node.js environment. As you've seen in my previous messages, I've asked you to install the Node.js environment on your machine, and we are going to produce the code and download it, and then just starting writing some section in it, just to give you an example of what does it mean to implement an API which has been specified in the OpenAPI standard. So I'm going to first of all, the example that I'm going to show you now, it's I mean, we're not going during this lecture to implement this job description API example. We're going to use a very simpler API that is going to be really there to show you what are the minimal requirements for and the minimal information that you need for producing then your API for your application. And so what we are going to do is to create an API for a very simple bookstore. Okay, so I'm going to let me just increase the fonts so that you probably are going to see better what I'm trying to do. So let's remove the all the original data associated with the jobs API, and we're going to start to write a simple API for a very simple bookstore. So first of all, we have to say that the standard version of that we're going to use is called 2.0. There is also a 3.0 version that we're not going to use, okay, during these tutorials. Let's say we're going to use the 2.0 the version. So we are going to provide an info field which is describes description and we're going to provide a very simple bookstore API with with users and a shopping cart. And the version of our API, it's going to be 1.00, and our title, it's a simple bookstore. While we are writing, you can see that the editor provides us with some messages that somehow at runtime validate the API that we are writing to see that it's coherent and consistent with the specifications. So that's pretty much helpful. So I will provide a contact. And license, I mean, all things that for the moment are not important. Okay. So this is info. Okay. So now it tells me that there is a problem. Contact should be an object. Okay. See, contact. It's an email must be provided. Okay, and the URI probably it asks for something like let's see whether, okay. I mean, this is metadata that is not going to be important for us, just to, you know, be consistent with the, with the required data, but for the example that we're going to write are not important. So the editor signals us that there is a missing property paths, and we have to provide it. The paths property is, as you have seen before, the the part of the specification that provides a way to say how calls to the various API endpoints must be formatted. And just before describing this paths component, we're going to fill up the remaining metadata, which is the address of the of our server, which is, for the moment, it's something which we don't know actually, which actually we can even say that is localhost. Okay, for the moment, we don't have yet a running server. We're going to modify this bit whenever we have a server running somewhere in the cloud. And then we can specify an option-based path which allows us to provide a versioning of our API. For example, I can say that is the this describes that /v1 the API available at the /v1 sub URL. Then we fill up with a set of tags which describe the which allows us to categorize the to somehow structure the documentation associated with the API by collecting objects and resources associated with the same tag under the same section. So we're going to have a book, which is the store. We will have a cart, which is a cart actually, and then a user, and this is operations. Operations associated with user management. So let's start with the paths component. And the first thing that we're going to provide is a way of accessing the collection of books. This is something which we think it's probably standard for an API that provides access to a store of items, and in this case a store of books. So we say that we can have the books endpoint, and we can do a get to the books endpoint, and the results of a get to this endpoint provide books available in the inventory. And we're going to give a tag. You might want to give a single tag to the one or more tags, and in this case we're going to give a single tag to the get endpoint, which is in this case it's associated with the book management. And you can see here that the tags are already used for structuring the documentation, and the fact that we have said that the get operation to the books endpoint must be associated with the tag book, allowed us to generate a documentation here on the right that in the section book has the get towards the books endpoint. So it's a way of structuring the documentation, providing tags. And we go on. So we have to provide also. This is kind of redundant. You can provide also a description other than a summary, and this can be something probably a little bit more long than the summary, and it's going to be used, the description field, to really fill up the content of the detailed description of the meaning of a get towards the books endpoint. So let's leave it like this. We don't really want to produce any other, let's say, detailed description of the API of the get to books. Okay. And then we must define what is the representation of what is the language used for representing the objects associated with the results of the get to the books endpoint. And in this case, we're going to provide a media type, which is the application/JSON, which says that the language used for describing the returned data is JSON. Okay. Then we want to provide this /books endpoint with a way of, without any additional parameter. A request towards this endpoint would provide us with all the books in the store. Now, it can be cumbersome to really deal with hundreds or thousands of books, of course, and you might want to provide in the specification of the get a way of limiting and paginating the resource, the number of results. Okay, so we're going more or less to follow the same example as the jobs API. We're going to provide a way to specify a limit. This is in the field parameters. So we're going to provide a name limit, and the value of limit will be in the query part of our API, of our URI, sorry. And we can also provide a description here. This is a description. This is the maximum number of items per page. And we specify that this must be an integer. Okay. So now, whenever we have a limit, we must also provide a way of specifying. Limit. It's a way of specifying the size of the result set. Now we want to provide a way of, let's say, select which part of the data, assuming that it is ordered from, that we order the results from 0 to max, the maximum number of items stored into our bookstore. And so we're going to provide a way to specify from where that amount of results we want to get, from where within the overall result set we want them to be provided. So this is the offset field, which is always in the query part of our URI, and this is a way of this is called the pagination offset. And typically, if you don't provide an offset, this starts from the item number 0. So default is 0. And this is still a type integer. And that's pretty much what we need for getting a subset of data. Specifying the size, specifying the index within the overall result set, the offset within the overall result set from which we want to get that amount of data. Now, the other example of parameter that you might want to insert into your API, consider inserting into your API, it's called the, it's a generic search within the books collection, okay? You don't typically provide in a REST API a specific endpoint for doing searches, but you might want to really use an additional parameter, which is called search, or whatever you might want to call it, where you might want to specify, this is still in the query part, where you describe, this is actually a generic text search, and the value of this parameter is a string that you are going to search within the books repository, and return only the data that contains that string, for example. And you might want to combine this with the limit and offset to really get a subset of items that, for example, match a specific string. So all these parameters must be, interpreted as interdependent, so somewhat, whenever you are going to write the code that answers to that to this API call, to this GET API call. And then, so we're going to provide the set of responses that must be provided back to the client. And when, if you remember correctly, we have to specify the status code that must be returned, and the structure of the data that is returned with that specific status code. For example, for 200, which is the successful status code, we're going to return a collection of books, which is a schema, which is an array where the items are have a certain structure, okay, and we the structure is encoded in the same file under the definitions book field. Okay, now we're going to write this structure, and to do that we have to so for the moment let me just complete the other response that we can get. The other is 404, which is, you know, an error. It's part of a set of status codes that signals an error. Now the choice of status code must be probably much more careful than what we're doing here. We're just, you know, subdividing in either success or complete error. Now you might want to really study a little bit when and if certain status codes must be preferable to other for that particular type of response. Here, description, it's unexpected error. Now there is an error here. Let me just check. Okay, so there is no definition book that I'm going to write now, so I'm going to write it here. So we're going to write the sections, the section definitions. So the first definition is the book definition. And this will have a title, which is book, and description, a book for sale. And this is an object, so it's a structured data, which has the following properties. It has a ID, which is an integer. And this integer has a format which is, you know, a 64-bit integer. Then we have a title, type string, and we can also give examples, and these are useful for the documentation. Okay, we're going to check that. So as you can see here, the models section of the APIs has already been built with what I'm just describing here, and it uses you know, several it uses all the fields that I'm describing here, just, you know, formatted in a nicer way. But as I was telling before, we can also specify examples that can be used for describing the API. And for example, in this case, I'm going to provide an example book. Oops, I just probably closed the window. Let me reopen it. Sorry, technical problem. Okay. So as I was telling before, we must provide, we can provide an example. In this case, I'm going to put the title of a very famous book and author, type string, example, the name Dino Buzzati, which is the author of the Deserto dei Tartari. There is a price, of course, books have price, which I'm going to describe with another type. Which is the type amount, so that the books can have a price in dollars or something something else. And the book can also have a status. I mean, if it is available in the repository or not, in the inventory. So this is a string. And we can also specify some that these strings can be only of a certain within a certain set of available strings, and this is done by using an enumeration type, which is, for example, in this case, we can have either available or out of stock. Okay, and then, as I said before, the amount it's going to be the next type that we must write. The amount it's another definition that we're going to put in the same section. The type is going to be object, and the properties are going to be value, and the format of this value is going to be double, and this is a type number. You can even provide a minimum and maximum for this number. And the second field is the currency in which the value is provided. So just to show you what can be the capabilities of structuring objects within the API, I'm going to provide a currency, which is another reference to a currency object. And the currency, it's another object that describes, it's a string, and you can describe even, you know, a regular expression pattern. But we're going to not do that, and an example, which, for example, an example of currency, it's euro. Okay, so this is pretty much an example definition of API that we can describe with the OpenAPI standard. Now, when we generate the server, so we generate the skeleton code that then we must the skeleton code actually provides a way of when you install all the dependencies, provides a way of you know, answering to the requests coming from the clients with the fake data, and then there is the whole connection to the actual data that, in this case, the bookstore, for example, would have to provide, that is still to be implemented, in the sense that we can see as a starting point the code generated by the server, which we must then complete with by writing code, of course, by connecting it to the actual database that we want to use for providing this data towards the clients. So just to describe the structure of the code that is generated by the server, I'm going to generate it and downloading it. Okay, so it has been downloaded into the documents directory. And just to have an idea of what we're going to see now, before delving into the code, I would like to show you a picture, which is, coming back to the slide, which is the following. Now, this is more or less the structure of the server that we are going to build, and a very, very simple server that we're going to build during these lectures. So just by recapping what we are going to build, the application actually will be composed of several layers. We have the presentation layer, which is composed by the browser, and this browser will access some static assets that are going to be the HTML files, the JavaScript files, and so on, which will be provided by the server. Okay. This is not the static assets are provided by the server, but are not, if you want, really deeply integrated with the other part of the server that is used for providing data to the presentation layer. So our server will provide static assets, of course, to the browser, but will also, of course, provide data to the browser through the application server. This is a part of the application that is going to be composed by several modules. So there will be a, let's say, an interface toward the browser, which will provide the endpoints that we just specified in the API. This is automatically generated by the Swagger editor that we've just seen before when we do, generate server. And this is going to be generated by the Swagger editor. The other components here are still generated by the Swagger editor, but they must be, somehow completed with the, additional, let's say, code, in the sense that when we generate the code, actually we have that the controllers and the OpenAPI gateway that is already pretty much there, but we still have to complete the services modules which are needed for accessing the database. So this is still to be provided by us, okay, by modifying the code in the services and providing a way to access data and returning it back to the browser. But still, the Node.js skeleton that we just downloaded will provide a lot of code that otherwise we would have been writing from scratch. So it's a very good starting point. And so, having said that, let's see. Let's see within a shell. Let me open a shell now. Let me switch control back to the shell. Okay. Now I'm going to create a directory, which is let's call it hype example, and I'm going to move the server that we just downloaded. This one we just downloaded from the Node.js, from the Swagger editor here, and unzip it. Okay. So this is structure of the code. Let me increase the. As you can see, there is the structure of a Node.js program. It's typically composed always by a description of the package, which describes all the dependencies associated with the program that we must install before running it. And then there are four directories. The first one is called API. Let's see what contains. It contains a swagger.yaml, and if you open it, this is the actual description that we just brought into the Swagger editor. Okay, so there is a single file which is just the specification that we just wrote. Then we have other directories. The most important one are controllers, which represent the collect the modules that manage directly the calls from the browser towards the server. And then the service directory, which will have, let's say, code that will manage the access to the database. Okay. But before that, I would like to underline the index.js file. This is the main file. It's like the main in a C language. This is the entry point of our code. And this is going to be the code that will set up and start the server, the skeleton server, in the sense that it's going to be a very, empty server, but nonetheless, it's going to be running, and we will be able to at least do some example query towards the server, and they will provide us with example data, the examples that we have provided in the OpenAPI spec that we wrote. Now, before doing that, however, we have to check the package.json file. This file describes what this program is. It's actually going to be generated directly from the specification. So it's a simple bookstore. It has the same description that we put at the beginning, and you will have a section here which is it's called dependencies, and these dependencies are node packages that will be we must install before before running our server. And to do that, we have to we don't have to do it really for each package. We must simply do an npm. npm stands for the node package manager. Install dot. This is going to install all the dependencies, fetching them from the internet, and that's pretty much it. We just all got some messages which we are going to ignore for the moment, as they are not important. And so we have installed the dependencies. Now we have all the things that we need for really starting this server. And on my machine, of course, in this case, it's going to run on my machine, so I can test it from a web browser by pointing it to to localhost. And to do that, to launch the server, typically you just invoke the node interpreter, which is a JavaScript interpreter that you must have hopefully installed on your machine. And we're going to provide the index.js file, which is the main entrance point of our application. So when we do that, you see that a message, your server is listing on port 8080. Okay, this is HTTP. So if we go to this endpoint, to this address, let me just switch back to the browser. Yeah, unfortunately, tutorials over with several windows are pretty cumbersome, and one must switch from one to the other. So as you can see here, I just opened the Chrome web browser and pointed it to localhost 8080. And as you can see here, there is anything. The answer it's just an error. I cannot get slash. Of course, on one side, I could have open, for example, the developer tools and do a fetch. Okay. On the other side, I could do since it's only a get operation that I want to test. I want to test the call to the books endpoint, which I just wrote. I will just provide in the URL part of the /v2, which is the version of our API that we had given to our API, /books, and it doesn't work. Okay, that's let's see why it doesn't work. Let's see, just 1 second. Okay, base path was v1, not v2. Okay, so okay, so as you can see here, this is just a get towards my running web server, and the get, if you do a get directly from the URL section of your browser, this is going to provide you with the window is going to provide you with a pure representation of the text received from the server. Okay, this is just to show you that if you just do a get to that endpoint, it's going to provide some example data. If you remember correctly, we just provide example data for the author and the name and the title and some enumeration for the status, and this is all generated, you know, from the examples. It's not going to be really something useful when you go on with the development of the server, but just for the beginning, you could even use it for, you know, writing the interface, you know, so it's a way to really get you started with the you know, developing the other components of the application, so that you have already a server with running example data that you can use for, you know, providing data to the application. And of course, I could even use the developer tools and do a fetch towards that endpoint to get the same data. Now I'm not seeing the chat of whether there are questions. So sorry if I missed. Wow, I missed a lot of questions. Sorry. So I'm going to answer them now. I'm sorry, but so Elena Palombini asked whether there are any relevant differences between JSON and YAML. There are no difference at all, actually. They have the same expressive power. Maybe YAML is a little bit less verbose. What is the offset used for? It's, as I said before, if you have a collection of, let's say, 20 books in your inventory, and you want to ask for, you know, only for 2 books, okay? The offset it's a field that you can use for specifying from where within the ordered collection of books you want those 2 books. So if you specify in a collection of 10 books that you want 2 books, so limit equal to, but you only want to get the 4th and the 5th book, you must provide an offset of 4. Okay, so that you get 2 books starting from 4. So does the indentation matter in YAML from Elena Palombini? Yes, it's important, as Filippo Maria Benati has correctly pointed out. Sorry, but unfortunately, with all these windows, I wasn't able to really catch up with the messages over the chat. However, feel free to just write questions over it. Okay, so now we have our server started, but we don't know yet what's the content of the server that we are running. What's the code that is able to really run this server. Now, before going into that specific topic, which will require a little bit of JavaScript skills from your part, I want to really have a look at another thing that the API is going to the fact that describing the API with a standard is able to get us. As you can see here, we have a localhost 8080. We want books. This is the actual endpoint that we must use for accessing the books. But if we go to the /docs field, URL, we get the automatically generated documentation which describe exactly the which describes exactly our API. And as a matter of fact, we are also able to test the API on the running server directly from this. So, for example, this is probably, let me check whether this works out, try out. Now, the fact that it doesn't work is that I must, let me see whether it's possible to do it from here. I don't think so. I must modify the OpenAPI specification because to test, to actually make it work. As you can see here, it accesses HTTP localhost, but the server now is running on localhost port 8080. So the host section of the Swagger or OpenAPI specification must describe exactly the actual URL of the server with the exact port, something that which we did not. So I have to, let me switch back to the shell. So let me open the API Swagger YAML. And as you can see here, I just provided a host, which is localhost 8080, I should put. And let's restart the server. Now, if I go to localhost, let me just switch the window back to the Chrome browser. Now, as you can see here now, the documentation that is generated accesses correctly the endpoint, and you are able to press this button, try it out, and it does the request towards the endpoint and provides a way to format it. In this case, we get the same example data that we got by directly, querying the endpoint from the URL of the browser. So we are able to, with the Swagger editor, generate the code for a server that provides example data, and we are also able. We will also get a running online documentation that of our API that can be used by developers to really make sure that they're doing the right thing. The front-end developers, to make sure that they are doing the right thing in accessing data on the server. Now we must. There is a little bit of study on your part on the structure of the index.js file that let me switch back to Interesting. I don't see. Okay. Okay, let's just stop the server and let's have a look into the index.js file. Now it's a JavaScript file in the end, and it's a JavaScript file that, of course, it's not going to run in the browser, but it's going to run on your actual machine. And but the syntax it should be very familiar. The only thing that it's probably not really familiar is the way in which packages and then the modules are loaded into the server. They are loaded into the server by using a require instruction. And now the important thing that we must really understand in this file is that it must set up all the connections that have to be set up to really answer to the requests coming from the internet, actually. And the module that does this, it's called the connect module. And when we require the connect module here, this set up an object which is called the app object, and this app object is used for describing the way in which it must really answer to requests coming from the internet. So the first thing that we must do, however, now is to we're not going into much details into how this code has been generated and why it has been generated in this way. What we must do now, because we're not going to modify too much this file, okay? The only thing that we're going to do is modifying it to provide a way to serve the static assets. Let me switch back once more to the slides. Okay, so the code that the server that now we are running, the example server, it's let's say it's a skeleton of the application server here. Okay, so there is the set of functions that manage the requests coming from the browser, and then we have the controllers and the services, the skeleton of the controllers and the services. Okay, so that's the let's say the path through which the browser can fetch data from the data layer, from the database. Okay, but we need also to modify this server also to serve static assets, to serve HTML files and so on to the browser. So this green part here, we will put it into the same application server, just to have it all self-contained, so that when we start the server, we also start the, we are also able to get the the files that we need for rendering the user interface on our of our application. So let me just see whether there are questions. Okay. Having said that, how to do that? Now, as I said before, we're going to modify very slightly the code of the server, the index.js. But in order to serve the static assets, we must, let me switch back to the shell here. Okay. we must install an additional module, which is called serve-static. Okay, and I'm going while I'm installing this package, I'm going to tell to npm to also modify the package file, the package.json file, to save this additional dependency. And I'm going to use the option -se. Okay. Now, there are only 2 minutes left, so let me just finish up with this. Now that we have installed the package, we have to load it. I'm going to use a var serve static, so I'm going to require this file, and I'm going to use it to tell the app object, which, as I told you before, it's the object that is used to, let's say, modify the way in which the browser, the server answers to the requests coming from the browser. I'm going to tell to the app object that whenever it receives requests towards a specific, endpoint, and in this case, it's going to be the default root of our server, it must serve it must send back copies of files available in one of the directories of my project. Okay, so I'm going to tell the app object just after the last app.use, which sets up all the routes towards the endpoints of my API. I'm going to tell it that I want to use also the serve static module, and I'm going to provide the current directory plus the subdirectory www. So this is going to be the subdirectory www of my project. And now, whenever the server is getting requests towards the root of my server, actually, towards the root. So not /v1/books and so on, but whenever, for example, it receives a request towards /index.html, then it must look for that file, index.html, into this directory. And that's the way in which you set up serving static assets. Now we're going to get back on this on next week, Wednesday, because the time is up. And yes, sorry for the confusion with the windows and so on, but it's a bit cumbersome. I will learn with time. So if you have questions, I'm available to really answer here. And sorry for not having seen your question over the chat, but I'm here to answer all your questions. And for all the other, thank you very much for being here, and see you next week. Okay, looks like there are no particular questions. I'm just going to stop recording.